we need to know what momentum is. We define momentum as a product of mass and velocity. Okay, so momentum is simply mass times velocity. Now look at this. The symbol for momentum. Now here we are talking about linear momentum because we also talk about angular momentum. But the angular part we'll talk about when we start talking about what we call rotational motion. So linear momentum is given by the symbol P, and that's given by mass times the velocity. Now you know that the SI unit for mass is a kg, the SI unit for velocity is meter per second. So this is the SI unit for momentum, kg meter per second. So what happens is that when you have got an object that is not moving, because this object is not moving, its momentum is equal to zero because velocity is zero. So mass times velocity will also give you zero. When it starts moving, it will gain momentum. So let's say you have got this object which is moving and then it comes and hits, and let's say it is moving at a certain velocity v. Let's say v is equal to 10 meters per second, and then it finds an object that isn't moving. This object is stationary, and say this first object has got a mass of 2 kg, the second object has got a mass of 1 kg. And what happens that once these guys hit each other, let's say they start to move together, they are now stuck like that. They are stuck. So I want to find what is the velocity at which these guys are going to be moving together. The way you answer a question like that one is you use what we call conservation of momentum. For any problem that you are given, you need to know that momentum is going to be conserved. The meaning of that is that momentum, the initial momentum, if we say initial, we are saying the momentum before this object hit each other should be equal to the final momentum that's after hitting each other. So the initial momentum before they hit each other, let's say this object we call it 1, this object we call it 2. So object 1 has got its own momentum, object 2 has also its own momentum. So say m1 multiply with its initial velocity we use u1, and then plus m2 multiply with its initial velocity u2. It should give you the final momentums. So we'll say momentum is given by mass times velocity. Since we're talking about final momentum, is going to be final velocities for each one of the objects. So we'll say m1 v1 plus m2 v2. So these are the sums of the momentums at the end. Now, because these two objects are stuck together, we are going to take that their mass is actually the same, and they'll also be moving at the same velocity. So we'll simply say the final momentum will be m times v. This m is capital. It's a combination of the two masses because they stack together. So what is m1? The mass 1 is 2, and it's moving at a velocity of what? 10 meters per second. The mass 2 is the second mass is 1 kg. It's not moving, it is at rest, so the velocity is 0. It doesn't have momentum. That will be equal to mass. Now, if you combine these two objects, their mass is going to be 2 plus 1, that's a 3, but we don't know the velocity which they are going to be moving at. So 2 times 10, that is a 20, and that is going to be equal to 3v. And then we want to remain with v, so simply divide 20 by 3. And so v is going to be equal to 6.67 meters per second. That is the final velocity at which these two objects are going to be moving. Does this make sense? Are we okay? So momentum before impact is equal to momentum after impact. That is known as the law of conservation of momentum. Now, when it comes to collisions, you have got two types of collisions. When you have got a ball here, men or the guys who understand this well, if you are playing pool table, you have got this ball here and then there's another ball there. If you come and hit at this corner, what you see is that the first ball will end up going in this direction. The second ball end up going in this direction. Let's say this is A, this is B. So after impact, the A will go up and then B will come down like that. They are moving at an angle. You can see these two angles here. So in elastic collision, what you need to know is that momentum is conserved and kinetic energy is conserved. When you have got an object, it hits another object, and we say that collision is elastic. It means that it's going to be the momentum that you have at the beginning should be equal to the momentum that you have at the end. And at the same time, the kinetic energy of the two balls, if you get the kinetic energy of the first ball plus the kinetic energy of the second ball, it should give you the final kinetic energy. So you can see this is the first ball M1, this is the second ball M2. Okay, when this one is moving and then even this one, let's say it's moving or even if it's not moving, so when you find first your momentums, so momentum of this ball at the beginning is going to be given by, remember momentum is mass times velocity, so that will be mass 1 times initial velocity 1. The momentum of this ball at the beginning is going to be mass 2 times initial velocity 2. When they hit each other, now we're supposed to find their final momentum. So when they hit each other, this ball M1 is going to have the final momentum, and that will be given by mass 1 times now final velocity for that ball. And then also you get this second ball mass 2. Now you are using the final velocity for that ball. This equation is known as the conservation of momentum. Now for elastic collision, it's not only momentum that is conserved. Kinetic energy is also conserved. How do you find kinetic energy? Kinetic energy is given by half mv squared. And I've just said that momentum is given by mass times velocity. So we are first going to, since kinetic energy is conserved, we'll find the kinetic energy of this first ball at the beginning. And we also find the kinetic energy of this ball at the beginning. We add them. It should be equal to the kinetic energy of this ball plus the kinetic energy of this ball at the end or after collision. That is the conservation of momentum. I mean kinetic energy. So we are saying half m1 u1 squared plus half m2 u2 squared, coming from this equation for kinetic energy, and that should be equal to half m1 v1. Remember, v is the final. v1 squared plus half m2 v2 squared. So this equation is giving us a conservation of kinetic energy. Have I left out anyone? Is there anyone that has remained behind? Yes? Where are you behind? So if you are behind anywhere, you can open your mic and be able to speak. Otherwise, I might not be able to help in that case. Okay, so now when you understand, yes, please. It's equal to, yes. No, it's actually the same balls. Let's say you have got this ball, right? This is A. And then you have got also this ball, which is B. So if these balls at the beginning, this A is moving, B is also moving. Sometimes maybe one of them is not moving. But at the beginning, when I shoot ball A, imagine I'm playing put table, I shoot ball A against B. A has got a momentum, and we can find this momentum by saying the mass of this one times, because momentum is mass times velocity. But in this case, it is the initial velocity, so I'll say m times u. So just to differentiate from both two, I'll say this is m1 and the u1. So this is the initial momentum for A. The initial momentum for B is going to be given by m2 u2. Now, when these two guys hit each other, now that they've hit each other, you are going to have ball A there, and then you are going to have ball B here. So A has got a different velocity now after it strikes B, and B will also have a different velocity. So to find their final momentums now, it will be m1, the mass of the ball A, multiply now with the final velocity v1, and then for B also the mass, and then multiply with its final velocity. So from the conservation of momentum, when you add the initial momentums, the m1 u1 plus m2 u2, it should be equal to the sum of the final momentums, which is equal to m1 v1 plus m2 v2. Okay, great. Is there any other question? Okay, so I don't want you to forget these two equations that I've written here. I want to show you how we derive an equation that we use when we are talking about elastic collision. Okay. So we have got the equation for conservation of momentum and the equation for conservation of kinetic energy. And then, so using those two same equations, we derive other equations. So you can see this equation, I already gave it. This one is coming from the conservation of what? Conservation of kinetic energy. I said that half m1 u1 squared plus half m2 u2 squared is equal to half m1 v1 squared plus half m2 v. So what is just happened here is that, look at this. I don't want you to get confused. Okay. Can you see that at the beginning we just had the initial velocities, and then at the end we have got the final velocities. So the final kinetic energies, we are adding them together. The initial kinetic energies, we are adding them together. But what I've just done is everything that has got a 2, I'm taking it to the same side. So this one, half m2 u2 squared, I'll take it this side so that it can find this one. Okay. So meaning that this one will end up getting a negative sign. And then this one, which is a half m1 v1 squared, I'll take it this side so that it ends up finding the half m1 u1 squared. And the reason as to why we are doing that is just pairing up like terms. And so that is what you end up seeing here. So can you see? We now have half m1 u1 squared. Now it has become minus half m1 v1 squared. You can see it has become minus because we took it from the other side. And then we have got half m2 v2 squared. Because we had gotten this guy from the other side of the equation, it has become negative half m2 u2 squared. Does that make sense? Is this okay? Good. And then the next thing that is happening, can you see that half is appearing all throughout the equation? So it can cancel out. So we'll just remain with m1 u1 squared minus m1 v1 squared is equal to m2 v2 squared minus m2 u2 squared. Okay. And then on this other side of the equation, can you see that m1 is common? So I'll factorize out m1. And what has remained is u1 squared minus v1 squared. The other side of the equation also, can you see that m2 is common? So I'll factorize it out. And then we remain with v2 squared minus u2 squared. Okay, I hope that makes sense. Now remember from your high school in mathematics, you talked about the difference of two squares. When you have got u squared, let me use a different color here so that when you have got u squared minus v squared, it's the same as u minus v and then u plus v. Do you remember this? How to factorize a difference of two squares from your high school? So this is what we are going to use here. This simple equation of factorization. So because we have got u1 squared minus v1 squared, can you see that that's the difference of two squared? It can become u1 plus v1 and then u1 minus v1. Same here. Since we have got v2 squared minus u2 squared, we are going to have v2 plus u2 and then times v2 minus u2. Does that make sense? Excellent. So it is now from here we have formed the first equation. This is the one that I've labeled equation 1 there. And what we do from this point is we now bring our equation for conservation of momentum. Remember from the conservation of momentum, what did we say? We said that m1u1 plus m2u2 is equal to m1v1 plus m2v2. Okay, this is from conservation of momentum. And again at this point I want to pair like terms. So this one that has got m1v1, I'll take it this side where there is also m1u1, and then this one which has got a 2, I'll take it also this side so that we again pair like terms, and that is what now gives us m1u1 minus m1v1. And then the other side of the equation we are going to have this m2v2, and then this m2u2, if it goes the other side, it becomes negative. And can you now again see that here m1 is common? We'll factorize it and then remain with u1 minus v1, and then also here m2 is common, we'll factorize it, so remain with v2 minus u2. Does that make sense? Excellent. So yeah, so this is the second equation, equation 2. And now what we'll just do is we'll get equation 1 and divide it by equation 2. So we'll say 1 over 2. Okay, get equation 1 divided by equation 2. So equation 1 was m1 u1 plus v1, and then u1 minus v1 is equal to m2 v2 minus plus u2 v2 minus u2. I've just copied equation 1 on top, and then I've also copied equation 2, which is this one, m1 u1 minus v1 is equal to m2 v2 minus u2. I've just copied them. So what you end up seeing is that there's m1 down, there's m1 on top, it will cancel. There's u1 v1 minus v1, it will cancel with the u1 v1 on top. Same here, m2 will cancel with the m2, and then v2 u2 will end up cancelling with the v2 u2, which is on top. And then finally you end up having the equation, what will just remain is u1 plus v1, and then this side is equal to v2 plus u2, which I can also write as u1 plus v1 is equal to u2 plus v2. So from the this is the equation now that you need to know when you're talking about conservation of energy. In other words, when they tell you that this ball has undergone what we call elastic collision, in elastic collision we say kinetic energy is conserved. So from the conservation of kinetic energy, this is the equation that we use. The initial velocity of the first ball plus the final velocity of the first ball is going to be equal to the initial velocity of the second ball plus the final velocity of the second ball. That is from the conservation of kinetic energy. This is the final equation. This is the one that you need to know. Unless they ask you in the exam to derive, but barely will they ask you to do that. Instead, they are going to tell you, given that there is elastic collision, work out, they will give you a certain problem. Does that make sense? Are we okay? Good. So let's do a practice so that you can just understand. Let's say you have been given that you have got ball 1 which has got a mass of 4 kg. It is moving at a velocity of 5 meters per second. It hits ball 2 which has got a mass of 2 kg which is at rest. And then the question is, calculate the final velocities assuming a perfectly elastic collision. Perfectly elastic, it is first elastic collision, right? Meaning that kinetic energy is conserved. Now, in any type of momentum, momentum is always conserved, but kinetic energy is only conserved in elastic collision. This is perfectly elastic. These balls don't stick, okay? They don't stick. So, using the conservation of momentum, we'll say m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. The m1, the mass is 4 kg. The velocity initially is 5 kg plus m2, the mass is 2 kg, but it is initially at rest, so the velocity is 0. That's the 0 there. And that will be equal to m1, the mass is 4, but we don't know the final velocity, we just say v1. And then plus m2, the mass is 2, we don't know the final velocity at which it's going to be moving, we just say 2. And so 4 times 5, that will give you a 20. And then you have got 4v1 plus 2v2. Yes, I've seen a hand. Is that a question? Okay. So you can see we can divide through this equation by 2. Dividing through by 2 is the same as multiplying through by half. Half times 20 is 10, half times 4 is 2, half times 2 is just V2. That will be equation 1. And then from conservation of kinetic energy, we know that U1 plus V1 is equal to U2 plus V2. The initial velocity for the first ball is 5, but we don't know its final velocity, that will be v1. The initial velocity for the second ball, it was at rest, that is 0. We don't know its final velocity, that is v2. So we are going to end up with this side we just have v2, right? That's a v2. And then this side we have got 5 plus v1. This is the 5 plus v1 there. That is going to be our second equation. So the next thing is, now we get these two equations and solve them simultaneously. Okay, so what do? We'll simply get, can you see this is v2? We'll just come and substitute where there is v2. There we'll put v1 plus 5. Okay, that is what happens. So where there is v2, there we have put 5 plus v1. I'm going to take this 5 the other side, it will become negative, so it becomes 10 minus 5. Then I've got 2v1 plus v1, that will be 3v1. So we are now going to have 5 is equal to 3v1, divide through by 3. So we're going to have v1 being equal to 1.67 meters per second. So this is going to be the velocity at which the first ball is going to move after collision. To find the velocity at which the second ball will be moving, we'll just get the same second equation, v2 is equal to 5 plus v1. But remember, we found that V1 is 1.67. So V2 end up being 6.67. As easy as ABC. Is there any question? Any question? Are we okay? Okay. So last year's exam, where currently what is happening is that your friends have been begging to write supplementary exams and they've refused them to write supplementary exams. So they are repeating the entire just for failing one course. And I'm going to show you the questions at the end. It's the same simple things like this which you are saying. Imagine repeating the entire year for just one course, right? It's very bad, very sad. Let me give you another example. Let's say you have got a bullet here. This bullet has been shot from a gun and it is moving at a velocity of 100 meters per second. Let's say this bullet has got a mass of 2m kg, and then it finds a block, okay, which has got a mass of 5m kg. And then what happens is that when this bullet hits this guy which is at rest, it sticks. So it remains embedded. So the bullet is embedded within this block, and you have got your bullet there. And then these guys start moving at the same velocity, v. So what will be this velocity, v? Okay, what will be the velocity, v? How do you find that? We'll say momentum, the initial momentum is supposed to be equal to the final momentum after impact. Now, the initial momentum in this case will be given by m1 v1. Sorry, not v, right? Initial velocity we use u. I prefer using u, others are going to use v0. So m1 u1, and that is for the bullet. We'll call this as 1, and then the block we'll call it 2. So the initial velocity momentum of the block is m1 m2 u2, but because these two guys stick at the end of momentum, they have got the same mass, so just say capital M. They are also having the same velocity, just say capital V. Okay, so the bullet has got a mass of 2m. The velocity at which it's moving is 100. The block has got a mass of 5m. The velocity at which it's moving is 0. It's initially at rest. And then the combined mass, when these guys stick together, will be 2m plus 5m. That will be 7m. But we don't know the velocity at which they'll be moving. 2m times 100, that is a 200m. 5m times 0 is 0. And then we have got 7m v at the end. So can you see that the m will cancel with the m? So we remain with c. 7v is equal to 200. We want v, so divide through by 7. Therefore, v is going to be 200 over 7, and that is a 28.57 meters per second. Yes. Yeah. Pardon? The 7 is you've added the masses. Remember, the bullet has got a mass of 2m, right? And then the block has got a mass of 5m. Since they stack, their combined mass is going to be a sum of these two because they have stack. Does that make sense? Okay, one. So why haven't I removed the m? Okay, m is the actual mass. So m is telling us the mass, but let's say m itself, right? Let's say the mass m is 100 kg. But we are just saying that the mass of the bullet is 2 times 100. So m is part of the mass. It's part of the mass. It's part of the mass. So you won't just discard it. It's think of it as though it were a number. Okay, so you don't just discard it, you go with it until you simplify. Does that make sense? Okay, great. I saw another hand. Yes, Martin? Yes, it's a zero since that block was initially at rest. Okay. So that is about elastic collision. Now, another type of collision that we have is known as inelastic collision. But what you need to know about inelastic collision is that for inelastic collision, momentum is still conserved. Actually, for any type of collision, momentum is always conserved. But kinetic energy is not conserved for inelastic collision. That's what you need to know. And then sometimes they'll tell you the object has underwent what we call perfectly inelastic. So if you hear of perfectly inelastic collision, it means that after collision, the two objects that collided stuck together. That's the meaning of the perfectly inelastic. Okay? Objects stick. Let's say, for example, you have got these objects here. A 10 kg object moving at 15 meters per second moves and hits a 5 kg object, and then they stick together. And then they've got a combined mass. What would be their final velocity? We've been dealing with this one, right? What would be their final velocity? So I can make these two questions. I can say this is A. If they stick, find their final velocity. And then B, I can say find the loss in kinetic energy. Okay? Remember, we are saying that for any elastic collision, kinetic energy is not conserved. The meaning of being conserved is that it is converted to another form of energy. So now find the loss in energy. So for the first one, which is A, we've been doing this a lot, isn't it? So we are saying initial momentum should be equal to final momentum. Initial momentum is m1u1 plus m2u2. That should be equal to m times v. The mass is 10. It was initially moving at 15. The other one was not moving, so we are multiplying by 0. That should be equal to their combined mass. So their combined mass will be a combination of 5 plus 10, and that is what gives us a 15. And so find that they'll be now together moving at a velocity of 10 meters per second. So since this kind of collision is inelastic, it means that there is a loss in kinetic energy. So how do you find the loss? What you need to know is that the momentum at the beginning, you have got initial kinetic energy. So say kinetic energy initial, not kinetic energy actually. Let me make it more science in nature. Energy should be conserved. So the initial energy should be equal to the final energy. But the problem is this: the initial energy is only kinetic energy. We only have kinetic energy initially. So say kinetic energy for the first object plus kinetic energy of the second object. Now this should be equal to, because the two guys is stuck, we'll just say kinetic energy total, okay, like the sum. And then there's also loss. That kinetic, because at the end of it all, the objects are not going to have the same kinetic energy. There is loss in kinetic energy. So that loss is going to be another form of energy that you are going to have. All right. Let's say, for example, the loss in kinetic energy will end up forming what we call sound energy, or maybe potential energy, or it will be converted to another form of energy. So kinetic energy is given by half m, that will be m1 u1 squared. Now for the second object, at the beginning the kinetic energy was 0. Why? Because it was at rest. And then the final kinetic energy will be half. We'll use capital M and then capital V because they stack, and then plus the loss in energy. So this is going to be half. The first object had the mass of 10 kg, and then it was moving at a velocity of 15 squared, and this should be equal to half. The combined mass of the two objects is 15, and now they were moving at a velocity of 10 meters per second, and then we'll say plus the loss. So we are saying half, which is 0.5 times 10 times 15 squared. That is going to give us 1125. and that will be equal to, the other side we have got half times 15 times 10 squared, and that is going to give us 750, and then plus loss. So I'm going to take the 750 the other side. So we're going to end up with loss being equal to 1125 minus 750. And therefore, the loss in energy is going to be equal to 1125 minus 750. This is going to be 375 joules. It's energy, it's in joules. Okay, just the word loss means it's negative. So another way I could have done this is, it's easy guys, there are a lot of ways. Just the same question B, let me use a different color there. Just the same question B, I could have also said loss. How do you find loss? Just get a final energy, remove the initial energy. That's how you always find when you're talking about a difference. You always use final minus initial. So we'll say final kinetic energy minus initial kinetic energy. The final kinetic energy is given by half mv squared. And these are this, because they stack, these guys stack, their mass will be combined. And then the initial kinetic energy is only the kinetic energy for supposed to be half m1 u1 squared plus half m2 u2. But remember the 2 was at rest, so its kinetic energy is going to be 0, so we'll not include it. And this would give us half the mass, combined mass after collision is 15, velocity is 10 after collision squared, minus half the mass of the first ball was 10, the velocity at which it was moving was 15 squared. So this gives us 750 minus 1125, and that would give us negative 375 joules. So the negative in front means that energy was lost. It doesn't mean that it's different from this answer. Okay, it just means that this energy we are talking about is not a gain in energy but a loss in energy. That's why it is negative. Does that make sense? Great. Okay, so let's say we have got this one. You have got a bullet that you fire, and then it hits this block that is hanging on a rope, and the bullet has got a mass of 15 grams. It's moving at 350 meters per second. When it hits this block, it penetrates, and then they stick, and then the block gets to move. You can see there is this movement here. Okay, of course there is also an angle there. They can also ask you to calculate that angle sometimes, but I'll not show you that for now. Okay, I'll show you so that you don't. Yeah, so you have got them sticking. The question is, what will be this height h? Calculate the height h. And then what will be the final speed of the bullet and the block when they stick? What will be v? I can even add another question. Let's see if I've got space where to write. Okay, I can even add another question. Let's say you can see there's just some application of some physics here. Really nothing any tricky, just some application of physics. Let's say the length of this rope is 2 meters. We can even say part C. Can you calculate the angle theta? Now, one thing you need to know when you are talking about something that is moving like this, the energy at the bottom here is only potential energy. Every time you don't have height, you only have potential energy. And then by the time the object is moving at this maximum point, all the potential energy has been converted to kinetic energy. That's what you need to know. Very, very important principle. So the first question is, what is the final speed of the bullet? So you use conservation of momentum. Momentum before impact should be equal to momentum after impact. M1 U1 plus M1 plus this is supposed to be M2 U2 is equal to MV, right? Now, M1, that's a bullet. We are told the mass was 15 grams. You don't deal with grams, convert it to kg. So divide by 1000 to give you 0.015. And then it was moving at a speed of 350. The block which was hanging was at rest. Its mass is 1.2. Because it was at rest, the velocity is 0. And that will be equal to, now the combined mass. The combined mass is add 1.2 for the block plus 0.015 for the bullet, and that will give you 1.215 times v, which will be the final velocity. So you are going to find that the final velocity is going to be 4.321 meters per second. And then the other part of the question was saying calculate the height h. Okay, now remember we're going to use energies here. We said that the energy at the beginning was potential energy. It will be equal to the kinetic energy at the maximum point, right? So say potential energy is equal to kinetic energy. Potential energy is equal to kinetic energy. Now potential energy is given by mgh. So we are going to say the actually this object here and this object, they are doing two different things, and what I've written here is supposed to be the opposite, not what I've put here. So the object at the maximum point here is going to have potential energy. So potential energy is going to be maximum because that's where you have got height. And then here you are going to have maximum kinetic energy. At the bottom, the object is moving. At the top, it will stop moving because it wants to start coming back. Okay, that's why you have got kinetic energy, potential energy on top. So we are saying that the potential energy is going to be equal to the kinetic. The potential energy that we are gaining will be equal to the kinetic energy that we are losing. So the block will be losing kinetic energy as it moves from the bottom to the top. And the potential energy is given by mgh. Kinetic energy is given by half mv squared. So the mass will cancel out because it's the mass of the same object. So remain with gh is equal to half v squared. And then we'll cross multiply these two with the gh. So that will give you 2gh is equal to v squared. Okay, and then if you want to remain with height, divide both sides by 2g. So remain with height is equal to v squared over 2g. Now remember the velocity, the final that will be the velocity at which the objects are moving. Okay, the velocity at which the objects are moving. Now this velocity that we have calculated is actually the velocity at this point, because at this point the velocity is going to be equal to 0. Why? The object will stop moving because it will, what happens that when an object reaches a maximum point, it wants to start coming back down. So when it reaches this point, it will be coming back down again. So the velocity at this point is 0. So it is the velocity that we've calculated is just the velocity when the bullet hits the block, that velocity at which they will start to move. That's what you need to know there. Okay, so velocity is 4.321 squared over 2, g is 9.8. So we're going to find that the height is 0.9526. Now to find the angle theta, remember how this guy is. So for the angle, we have got something like that. Here is our object that is hanging there. And then it went like that. Okay, so something like this. And then I said the, okay, let's say we were not even given the length. Okay, let's say we are just told that the length of this string is just L, so that we don't deal with numbers. In case you see they've not given you numbers, you start wondering. We want to find the angle theta here, and this is L. And we've just calculated that the height, this distance from here up to here, is what? We've calculated that that is H. Are we moving together? I want you to follow this well. Is this okay? Remember again, this is string, the length is what? It's L. So if I do this, I want to make a triangle. If I do this, what will happen is that this is now 90 degrees here. So since the entire of this thing is L, but we know the distance from here to here. Anyone to tell me how can I find this distance here? This one. Anyone? Simple mathematics there, nothing complex. So this distance is going to be length minus height. Okay? Just remove the height. The height is this one here. This is H. And then the entire of this thing is L. So if you want to remain with only this part, just say length minus H. Hope that's okay. And we know from our physics, so now we have got two sides here. We have got this side that is adjacent to the angle, and then we have got the hypotenuse, which is the length. So we have got adjacent and the hypotenuse. What trig ratio can we use? We use cos. So cos theta is given by adjacent. The adjacent side to this triangle is L minus H over the hypotenuse, which is L. Therefore, this is going to be cos theta is equal to L minus, remember what was the height? The height is 0.92, 0.9526, and then over the length L. All right, there. And so this is going to be cos theta is equal to, we can get to split these two guys, but like that we can't do anything at this point. Okay, so for this one, I'm supposed to specifically at least have my length of this entire string instead of just L. So let's say the L was given. L is equal to 2 centimeters. Okay, let's say we're dealing with centimeters. Now if we're dealing with centimeters, it means that it won't balance with the units that we are dealing with for the other one. So let's say the length was 2 meters. So now supposed to come and make substitutions where there is length. We are going to put 2 minus h is 0.9526, where there is length again we'll put 2. So this will give us cos theta being equal to, we have got 2 minus 0.9526, and that will give us 1.0474 divided by 2. And then cos theta is going to be equal to, so 1.0474 divided by 2, that will be 0.5237. So theta, therefore, for you to find it, will take the cosine inverse of 0.5237, and theta therefore is going to be equal to 58.4 degrees. So that is the angle that this is going to be able to make. Okay, that is how you calculate that. Now let's say you add a bullet. This bullet went and hit the block that is not moving, and then the bullet, instead of sticking, it moved. and it was initially moving at a velocity of 400 meters per second, and then it pierces this object and then moves. The velocity decreases, now moving at 150 meters per second. So what will be the final velocity of this block when the bullet emerges? So simply say m1u1 plus m2u2 is equal to m1v1 plus m2v2. The bullet has a mass of 25 grams. Convert that to kg by dividing by 1000. That will be 0.025. It was initially moving at a velocity of 400. The block was not moving. It has a mass of 1.5 kg, but its velocity was zero because it wasn't moving initially. After momentum, after impact, the bullet is still having the same mass of 0.025, but now the velocity reduced to 150. And then plus the mass of the block is 1.5, but we want to find out the velocity at which it will be moving, v2. So 0.25 times 400 is a 10. 0.025 times 150, that is 3.75. And then we have got 1.5 v2. Take this 3.75 the other side, so it becomes 10 minus 3.75. That will give you 6.25. That will be equal to 1.5 v2. Divide through by 1.5. That will give you, the block will gain a velocity of 4.167. So that is the velocity at which it will now be moving. Okay, it's as simple as that. So I want you now, these are the questions from last year's exam, which I want you to do as your practice questions. You should send the answers in 30 minutes, right? 30 minutes is really a lot. You can screenshot this question, or I'm going to send the questions in the group. In an elastic collision, you pick. So this question is 2 marks. If you get, so the way the instructions are is that if you get it correct, you get 2 marks. If you get it wrong, you will be removed 0.66 marks. If you leave it empty, you get a 0. So you can answer that. A 30 Newton force acts on a body moving with initial momentum of, find the body's final momentum. Now, just one last concept that I should talk about for you to be able to answer that. We have got what we call the momentum, impulse momentum theory. Impulse momentum theory. The impulse momentum theory just tells that the impulse is equal to change in momentum. Now, impulse is given by force multiplied by change in time. And that is equal to, change in momentum means final momentum minus initial momentum. So this is all you use. Force is the force applied. This change in t is the change in time. Okay, after impact. What is the change in time after impact? That's the one that you use there. So that's the one you are going to use. A force of 30 newtons acts on a body moving with an initial momentum of 10. Find the body's final momentum. So after 3 seconds, so I've given, all the data is already given. Just make substitutions in this equation. What is a collision called when colliding bodies are deformed? So after deformation, what is that collision? Find the momentum of a body of mass 4 kg with kinetic energy of 32 joules. So here we've been given kinetic energy. We want to find the momentum. It's all from here. Okay, from the impulse momentum theory. When you've been given kinetic energy, you can actually calculate velocity, the final velocity, because kinetic energy is equal to half mass times velocity squared. So find the velocity and come and use it to calculate the momentum. And then you have got this. You want to calculate the impulse delivered to the car and then the average force exerted on the car. And then you have got this one. You also have this one. So let me just send a PDF so that you can be able to answer these questions. And that is where we end. In case you want to continue learning with us, you can you can do your registration by registering with us. We are having a promo of just 85 for this course, and for the other courses, biology, mathematics, and chemistry, the entire month. Thank you so much. Have a good evening.